Hi, I am Professor Yongjin Kim at Sogang University. This time I will explain digital transformation cases in manufacturing. You may hear of the digital transformation a lot, but the meaning is not very clear, right? Digital transformation can be defined as the status in that companies combine offline and online, control offline through online, and standardize, modularize their resources and processes, and convert them into digital so that they are able to have flexible, efficient, and effective ways of customer problem solving, as well as managing their resources and processes. When we say digital transformation as a process, it can be the process of converting analog to digital. Now, let's look at the examples of the impact of digital transformation in the manufacturing industry. The first case I would like to introduce is Budsys. I think you may already know this company, or even you have purchased something from this company. But the exemplary nature of this business pushed me to use this one here. Just imagine that you are making a stuffed doll. As a manufacturer, you cannot make only one of this doll. Why? Because this is too costly. To make a stuffed doll, you need to hire designers, buy textile, dye it, prepare molding for cutting the dyed textile, and seam them all. Problem is that you cannot buy 1 yard of textile, dye 1 yard of it. Making a mold to cut the textile is very expensive. So you are theoretically able to make it, but it is too costly. You cannot make it at $100. However, if you use digital technologies, you are able to make it happen. You pattern it through digital design. You print it using digital printer. You can cut it using digital cutter. Then you send it somewhere where labor cost is cheap to seam. You are absolutely able to make it happen at $100. This is how digital transformation solves the value-cost dilemma. The second case of digital transformation in manufacturing is Adidas Speed Factory. This factory was built as an exemplary case of smart factory in Ansbach, Bayern, Germany. Through the collaboration with Aachen Technical University, Adidas, and 21 software companies. It was designed to produce 500,000 units of jogging shoes per year. The factory was originally located in China, where it hired 600 employees. But in Germany, it hires only 10 employees with support of 2 sets of lines, each of which consists of 6 robots. With the factory, Adidas could cut time from design to market from 1.5 years to only 10 days. This factory is equipped with various digital technologies, including digital design, IoT, big data, and 3D printing. More importantly, when customers design their own style of jogging shoes, the machines manufacture a pair of shoes in 5 hours. Shoes usually consist of top part and bottom part. The most important bottom part is midsole because it is the part which absorbs the shock occurred when the user jogs. When Adidas developed a jogging shoes named Adidas Futurecraft 4D, it used 3D printing technologies to produce the midsole to personalize it to the individual's characteristics, such as weight, and height based on their 17 years of data and knowledge. The 3D printer Adidas employees is run on top of the technology called digital light synthesis, or CLIP, continuous liquid interface production. It is 100 times faster than commonly used layer-built 3D printer. With this 3D printer, Adidas does not need prototyping or molding so that they are able to proceed with the production faster. This way of jogging shoemaking can be defined as manufacturing on demand. The third example is Siemens. I'd like to introduce two things with regard to Siemens' case. The first one is their vision of digital transformation. As you can see in the picture, Siemens portrays smart manufacturing service in the form of digital platforms. The platform proposed by Siemens connect various services and smart machines. Services include new business models such as production capacity trade as manufacturing service and manufacturing data trade, crowd communities for manufacturing innovations, cognitive abilities to support remote control, automated marketplace to sell product and services, and various knowledge works and related services. Smart machines can be connected to the platform with plug-and-use functionality. Through this platform, people anywhere in the world can access smart machines to produce whatever they want to make and sell and wherever they want to make and sell. For example, an individual in Korea uses a design provided by a service to make it into product through smart machines and sell it in the US. This platform might change the whole industry shape, either manufacturing or services, as well as the value network or industry ecosystems. The second part of Siemens I'd like to introduce is the Siemens Smart Factory, in particular, Hamburg factory. By using digital twin, Siemens makes customer design product real time, ships 99.7% of product within 24 hours after customer's order, and achieves 0.001% defect rate. The productivity increases 13 times compared to the year of 1989 when Hamburg factory was built, keeping the number of employees the same. The smart factory uses IoT and big data too. By putting in place thousands of sensors and scanners on the smart factory and machines, they monitor product conditions through product life cycle and analyze errors. They analyze 50 million manufacturing data a day and make changes reflecting on the analysis real time and fix errors. Another, then the most important characteristic of Siemens Smart Factory is its personalization capability. Hamburg factory changes production line setup 5,000 times per year to produce more than 1,000 customized product. It is almost impossible for the traditional companies to change the setup this much. The last feature of Siemens is harmonious coexistence between human and machine. Machines replace simple labor, and employees perform advanced work like data analysis or systems management to improve productivity. This way, they could resolve the worry about unemployment, which may be caused by digital transformation. The fourth case of digital transformation in manufacturing is Burberry. Many people do not know how much Burberry is innovative in terms of technological innovation. Burberry built a website first in the luxury fashion industry, with which customers experience and shop. Burberry brand anywhere and anytime. It supports 6 languages and is available in 45 countries. It allows to send inquiries and to order product 24 hours, 7 days. You may hear of the term bespoke. Burberry is the first one which launched the custom manufacturing service under the name. It has digitally transformed its design, production, delivery, distribution, transaction process for customers to directly design and order trench coat of their own style. For that, it provides 1.2 million combinations of silhouette, textiles, colors, and designs customers can select from. Burberry has built a single customer view using big data analysis through which it can identify the type of product, place, time of customer purchase. It uses various digital technologies. For example, in their flagship stores, they have set RFID tags to product for customers to check them with a video clip through meters near the shelf. The fifth case I'd like to introduce is the digital transformation in the food industry. Climate change imposes huge challenges onto human society. One of the responses is the growth of digital transformation in food manufacturing industry. Just imagine how much of CO2 would be emitted when we grow cows in meadows and process the cow into meat to make a hamburger. Instead, how much of CO2 we can reduce if we can make the meat manufactured only with water, air, and protein. The key technologies used for this digital transformation in the food industry include 3D bioprinting and 3D printing, as well as AI, big data, and IoT. There are many companies which produce meats such as Beyond Meat, Impossible Food, Memphis Meats. Mufree produced milk with cow by using only water, air, and protein. Just produces eggs. And Finless Food fabricate seafood like salmon and tuna. The cost of inside lab-grown meat or seafood was very expensive. In the beginning, one hamburger produced by Beyond Meat was priced $20,000. But due to the development of the technologies, the cost gets down to earth. It becomes competitive. We will see a lot more of these tries in the near future. Thank you very much for listening.